at the origin, what would be the potential? 1 by 4 pi epsilon naught q by r. I don't do anything, just displace this by, say, z. Just displace this charged particle in the z axis here and try to find a potential at far away time. So this is my, say, r, the distance is r, z axis, and I am trying to find the potential at this point r. This is the vector, this is the vector, this is the z axis. What do you think? What would be the potential if the charge is displaced by the vector r along z axis placed here?
कैपिटल आर माइनस
कौन सा आता है, कौन सा पॉलिनोमियल आता है इसको सॉल्व करने एसोसिएटेड एज ए पॉलिनोमियल कुछ नहीं किया, बस आई जस्ट शिफ्टेड इट बाय आर. I don't know what differential equation is from associated algebra polynomial. And from that you get the idea of dipole. What will happen in case of a dipole? This is nothing but shifting here, right? There will be monopole term, dipole term, part of. If you put it at the origin, you have only monopole term, q by r. If you shift it from the origin, from nowhere you have dipole, quadrupole, octupole terms, right? So that would also tell us to do some problems of polarization on this issue, but this is the time for this. So what we will do today is quickly understand solution to the Laplace equation using rectangular coordinate, spherical coordinate, and cylindrical coordinate. Most of you will be doing this again in the math physics course, but I'll just try to motivate you in electrostatics. So, what is the Laplace equation in rectangular coordinate? Del square phi by dx square plus del square phi by dy square plus del square phi by dz square equals to 0. This is the Laplace equation in rectangular coordinate. X, y, z are my coordinates. Now the normal trick is that I take phi x, y, z equals to, say, capital X, x, y, y, and capital Z, z. And we had discussed the other day, not all mathematical functions follow this. If you have something like 5x plus 6y plus 3z, you can never write it as a product of this. But there is a very special technique, or Fourier technique, which is based on the completeness and orthogonality of sine functions. And we'll just touch upon why this is the general solution always can be written in this form, right? And if you substitute phi here, substitute phi x, x, y, y, z, z here, and then divide by x, y, z, what will you get? You get 1 by x, x, right? D square x by dx square plus 1 by y, y, d square y by dy square plus 1 by capital Z, z, this is a function of z coordinate, d square z by dz square equals to 0. Right? What did I do? I put this here and divide everything by x, y, z, and so y, z cancels out and you get this. And then we say that, okay, this has to be, each of them have to be constant. So I will take this as, say, minus alpha square, this is minus beta square, this is plus gamma square. This part is minus alpha square, so I can write d square capital X by dx square plus alpha square x equal to 0. Similarly here, similarly here. And then the additional conditions, these are all constants, alpha square plus beta square should be gamma square. Okay? What would be the solution to this? E to the power plus minus I alpha x. Right, cos alpha x. And this one would be e to the power plus minus I beta x. What about this? E to the power plus minus gamma z. Gamma z, small z. right? So the general solution therefore, phi x, y, z in rectangular coordinates is summation, we don't put the summation, so this is e to the power plus minus I alpha x, e to the power plus minus I alpha y, e to the power plus minus gamma z.
Beta. Second term में beta.
I. But then we said alpha, beta are all arbitrary. There will be infinite number of functions, and the example that we infinite number of solutions. But then the example that we took the other day, the rectangular slab, parallel slabs, they're very, using the Fourier technique, you could define what are the coefficients for which boundary condition will be satisfied, right? And for example, in our problem that we did the other day, phi xy turned out to be Cn to the power minus n pi x by a sine n pi y by a. This is what we did. This is a general solution, right? But then you have to fix your boundary condition using this. How do you get Cns and all that? Again, based on orthogonality and completeness. What is completeness, by the way? When you say that this function is complete. So if I have a set of function f and y, then f and y is complete when any other function fy can be written as summation Cn fi. This set of function f and y is complete if any other function fy can be written in terms of summation of Cn and fi. All that you have to do is to find the coefficients. What about orthogonality? What is the definition? Integration f and y f prime y equal to
delta n
delta n prime. Right? Zero if they are
same one.
So based on this, therefore you can calculate. This is a very general solution. Then there will be coefficients. Those coefficients you have to carefully find using this completeness and orthogonality of sine functions. And then you probably use the Fourier kick. What you use is multiply sine n prime pi by both sides, and use this orthogonality condition of the solution. So this is general solution rectangular coordinates. We did one example yesterday. Today we will let us go over to spherical coordinates. And just briefly, let me write down the solution to spherical coordinates, and then we'll do one example. What is del square in? So what are we trying to find? We're trying to find solution to the Laplace equation. Can you tell me what is the Laplace equation in spherical coordinates? Just one by one. I've asked you one square. 1 by r square, small r. Okay. Del square del r. Del r, okay. Del r, okay. d5. Right? This is the first term. Phi is my potential. Then plus 1 by r sin theta, r square sin theta. R square sin theta,
Sin
d by d theta, sin theta,
d of digital.
or partial d phi by d theta. Right? And then third term is 1 by r square sin square theta. Then we have d square phi by small phi square. This is capital phi, small. Right? This is the dependent r theta phi. This is the potential. Right? Equals to 0. Laplace equation in spherical polar coordinate. Right? There is the radial part, there is the theta part, and there is the phi. There is the angle phi, r theta phi. Okay. Here what will I put? this, again, this is a function of r theta phi, and that I would say capital R, small r, capital theta, small theta, capital phi, capital phi. This is not potential. This is the radial part is capital R, function of that, right? Again, you put it there, divide by r theta phi. Then you please quickly write it down. So you find this is 1 by capital R, d by dr, r square dr by dr, plus 1 by theta sin theta, d by d theta, sin theta, d theta by theta. Last term is 1 by sin square theta, 1 by effective q, q square, q by d theta square, d phi. Everyone agrees? तो ये r square तो हट गया, तीनों में r square का 0 से चला गया. तो इससे first term is 1 by r, second is theta, sin theta बच गया था, and then sin square theta q is the function of phi. ये सब लोग किए होंगे, हाइड्रोजन एटम में बार किया होगा, right? So you have to do it again, or let me just write down the solution. Just take your notes if you have problem with it. So the radial part, okay, first term is this is, you will see this is something like m square sin square theta, right? And so the phi part, therefore, we have 1 by q, d square q by dq square, d phi square. So this equals to minus m square, right? And so q m phi. 2m phi is e to the power plus minus im phi, with m being 0 plus minus 1 plus minus 2. So the phi part is very simple. Each of them will have to be constant. Right hand will be minus m square, and this is the solution. अब ये इससे फिर मैग्नेटिक क्वांटम नंबर कैसा आता है, सब आप लोगों ने बेस ने किया है. So this is what the phi part. What do you do about the radial part and the azimuthal part, theta part? Theta part का solution क्या आता है? Again, association का लेना पड़ेगा. उसमें पूरा एक L plus L पाना है. क्या बात है? Why L equal L plus 1? What is the reason for that? There is one constant. Always things will be equal to some constant. This will be equal to m. And the theta part will be equal to k square. Then you say k equal to L into L plus 1. Why is that? It could be any constant. What is the reason that k is L into L plus 1?
Normal.
Only L plus 1 stop the divergence. Integral multiple can be any other. Why? What is the form of L into L plus 1? First of all, do you agree that it is L into L plus 1? Azimuthal radius, right? With A मतलब दिया हुआ है, then the number of L into L plus 1. Why L into L plus 1? Okay. So let's just revise it quickly. What do you do for the theta part? So the corresponding equation, therefore, the theta part would be 1 by sin theta d by d theta. By the way, these are ordinary differential equations. This is partial differential equation. इसमें तीनों जुड़े हुए हैं. So that must be difficult to solve. So all this separation of variables, how does it help me? It converts a partial differential equation to an ordinary differential equation, which I know how to handle. Okay? So this is 1 by theta d by d theta sin theta d theta by d theta plus k minus m square by sin square theta, capital theta equals to 0. So this is the theta part. Does everyone get this? So this is my m square. This is m square. So this has a sin theta component. So entire thing has equal to k. So therefore m square sin square theta. The theta part corresponding theta equation is this, right? And then what you do? You say x equal to cos theta. Substitute x equal to cos theta. So dx equal to minus sin theta d theta. Then you can draft it, and x is varying from plus to minus 1. Theta is varying from 0 to pi. And the question that I am setting is, then you say that this is the only possible scenario. K equal to L square plus 1. So where L is equal to 0, 1, 2 and all that, M equal to minus L plus 1, 0 and then equal to 1. The very basic theory of international polynomial is magnetic quantum number and analytical quantum number. My question is, why is K constant here has to be L plus 1? Please divide this. Some people might know, but there's no harm in using this. What is the mathematical reason? That only if K equal to L plus 1, you find a तो जबरदस्ती हो गया लीजेंडर पॉलिनोमियल के लिए इसको एलिमेंट का लिखोगे पर नहीं आ रहा है के में रह रहा है तो वो लीजेंडर पॉलिनोमियल है ही इसका और कोई कारण है ट्राई टू फाइंड इट सो देयरफॉर देन यू कैन ड्राफ्ट इट इन टर्म्स ऑफ associated लीजेंडर पॉलिनोमियल एंड देयर इट विल बी dy dx 1 minus x square PLN x by dx plus L into L plus 1 minus m square 1 minus x square PLN x equal to 0. You are drafting this in terms of the associated Legendre polynomial. The solution should be PLN. Is there anyone who has done this before, other than you? Yeah, right? Okay. So PLMX, what is the solution? PLMX. So solution of PLMX is 1 minus x square to the power m by 2 dm PLX divided by dx to the power n. And this PLX is what I call Broderick's formula. You generate PLX by Broderick's formula. And PLX is given by 1 by 2 to the power L factorial DL dx to the power L x square minus 1 to the power L. Okay? X here, what is x here? Cos theta. So what is P0? P0x. P1x cos theta. P2x 3
cos square theta minus
3 cos theta.
cos square
3 or 3 by 2?
whole by 2
3 cos square theta
minus 1 by 2. नहीं 1 whole by 2.
minus 1
whole divided by 2.
Right? Some 17th century mathematician had written down this solution to this differential equation will be like this. And lo and behold, if you put a capacitor and you put a metallic sphere, right? The potentials will be given by this. That's the beauty of physics, string theory. Some differential equations solved in 26 dimensions. And lo and behold, that carries information about the treatment. All the forces, all the four forces that we have mentioned, collate into one equation in string theory, which is solvable in 26 dimensions by some differential equations. That is what they say that physics, the language of physics is mathematics, but no, it is very easy to do in mathematics, but appreciate the problem. To do an exact problem of a metallic sphere in a capacitor, and the potentials will be like this. E by 2 cos square will be cos square minus 1. Why is it related? Well, that is the physical intuition. One has to see much deeper into the problem like this. Okay, so this is my the theta part. What about the R part, the radial part? So what is the assignment here? Basically, a question I am asking you, you have done this before. What is the reason of k equal to L square plus 1? You have to prove that solutions become unphysical if k is not equal to L square plus 1 in the theta range 0 to pi. The theta is 0 to pi, x equal to cos theta. So x equal to plus 1 and minus 1. Solutions become unphysical unless k equal to k has the form L square plus 1. Right? That you have to see. Okay. So then what about the radial part? You can tell me the solution of the radial part. What is the radial part? 1 by RL R d by dr R square d square RL R
Only
dr, right, equals to what?
K square.
Equal to k is equal to L square plus 1. We know theta part and radial part, they have the same constant. So this is L square plus 1 and the solution would be RL R equal to R to the power L, rather than the solution is R to the power minus L plus 1. Two possible solutions. So therefore, my final phi R theta phi, separation of variable, solution to the Laplace equation, equals to summation over ln a ln AL R to the power L plus BL R to the power L plus 1 Y L n theta phi. What are Y L and theta phi? If you want to write it in full terms in theta and phi, so essentially you have let me write down in simpler way. So phi R theta phi equal to summation over ln A ln R to the power L plus B ln R to the power L plus 1 T ln cos theta e to the power plus minus I n phi. This is for the radial part. What I have written, the potential can be written as a product of R part, theta part and phi part. This is the radial part solution. This is the theta part solution. This is the phi part product of this. Right? The trick is to find the coefficients. Okay? And some of you might know that this theta part and phi part can be added as YLM. And again, YLM is a complete nature of theorem is satisfied. And therefore, the Fourier tree would work in this case. Okay, so this much of derivation, is it clear to everyone? I mean, I've rushed through it, but assuming that you have done it before, but if you have any problem, we can discuss again in the radial part. The only thing that I want you to learn here is that why is k equal to L plus 1, L plus 1, and why does the solution become uncritical otherwise? Now let's do this problem. One example, which we have done by using method of images, and the problem is the metallic conducting sphere in a uniform electric field. So I have a uniform electric field, and there is a conducting sphere in this uniform electric field. The physical example is that we have a capacitor that is producing uniform electric field, right? And in between the capacitor you have a metallic sphere, right? Dielectric material has some kind of metallic sphere or a defect, for example. As a finite conductivity. It's a perfect conductor, but you can have conductivity value, right? So if you are making capacitor, the dielectric is not perfect, then you can using this equation find out what would be the electric field or potential generated by that, right? Okay. So this is the problem. So my ER equals to EZ cap. So this is my Z cap direction. The field is along Z cap direction. Let us first discuss the result. What do you think will happen to the electric field? Will it be uniform here? Will the electric field be uniform here or non-uniform? Far away it will be uniform. Nearby these points. Non-uniform. Will it be function of r, theta and phi or only theta? We have understood that electric field could be always normal to the metal surface. So at the surface, it has to be radially outward. There will be no theta dependence. Outside, there could be a theta dependence. When the field line would just come and curve here. So nearby you have r cap and theta cap dependence. On the surface you have only r cap dependence. Far away it will be Ez cap. Right? So that is what we know. And would there be induced charge? Induced charge. There would be induced charge. So if it is in this direction, there would be electrons would move towards
left.
Electric field is this direction.
Force on the electrons will be the opposite direction.
So there would be, all the negative charge will be one side because negative charge are on the other side, the other one on the positive side. But the total induced charge will be zero. It is not grounded or anything. There is no electron coming and going. The total induced charge will be zero. Right? Okay. So we know what will be the answer. Let's try to do this in separation of variables. So the phi r, what would be phi r? Minus E dot dl. E is Z cap. I'm looking at dz direction. So this would be minus say some point C Z Ez cap dot Ez Z cap. So that equals to minus Ez plus C constant, and therefore is equal to minus E r cos theta plus C. So that equals to minus E r E1 cos theta plus C E0 cos theta. Most important part of this problem. If anyone hasn't understood this, please let me know. Far away, the field has to be Ez cap. And corresponding potential is E dot dl. You can't get it infinity, and then you get wrong results. At some point C, with respect to that point C, you want to find the potential at point Z. How much is that? Minus Ez plus C, and this is Z is r cos theta. Why? So this is your r. Z direction is r cos theta. So Ez is r cos theta minus r cos theta. C is the constant. And in terms of the, you know that in Laplace equation solutions are in terms of residual, associated residual polynomial. Cos theta लिखा, P1 cos theta. 0 percent 1 है, so P1 right? Okay. So there is an azimuthal symmetry to this. So the problem is phi independent. No phi here, only theta and r. Right? Azimuthal symmetry. Here with the chart reduced हुआ है, azimuthal symmetry. Right? Okay. And so what are the boundary conditions first of all? One, what about the potential? Potential at the surface of the sphere. So equipotential, so there is a phi naught at surface. Does everyone agree to this? That the potential will be constant. Why? Why is the potential be constant in this case? At the surface. Metallic conductor.
Electrical.
So यहाँ तो minus हो रहा है, यहाँ plus हो रहा है. Some part is giving more minus and some part is giving more plus. But still you are saying potential is constant. That's the right answer. Potential is constant. Even though the charge distribution is kind of non-uniform. It is not at all charges are uniformly distributed at the surface. Some side has more electrons, some side has more kind of lack of electrons. Even then, the potential is constant at the surface. Think of it for a minute, right? So phi naught is at the surface is constant. That's the first thing. So we would try with the solution phi r. Summation of L equal to 0 to infinity, all possible terms, AL r to the power L plus EL r to the power minus L plus 1. What else is there? What's correct? Someone from the पीछे के line. Nipun बताओ, what should I write here? I'm writing general solution to the Laplace equation in spherical polar coordinates with phi independence, azimuthal symmetry. So I have theta term and radial term. Radial term is this. What is the theta term? Yes, would be. What would be the? What should I write here? Very good. PL cos theta, right? Not PLL, because it is azimuthal symmetry. That m term, phi term has gone away. This is PL cos theta. There is the radial part and there is the theta part. Okay. So this is point number 2. Point number 3. I claim that B0 equal to 0. These A's are what? They are all coefficients. L equal to 0, this is A0, B0. L equal to 1, this is A1, B1. My first claim is that B0 has to be 0. What is the reason for that? R equal to anything solution will guide. L equal to 0 means थोड़ा फायदा है. L equal to 0 means this is A0, B0. I am not claiming A0. I am claiming that B0 has to be 0. What is the reason for that? Why should B0 be 0? Is there any free charge? Is there any free charge here? There is no free charge here. So, del square phi has to be 0. B0 का मतलब क्या है? 1 by r. So, del square 1 by r, we know it is Dirac delta function, 4 by delta. Since there is no free charge, it has to be 0. So, del square 1 by r has to be 0. Del square 1 by r can be 0 only when B0 equal to 0. इसलिए 1 by r term नहीं, ये r to the power 1. So, the first point is B0 equal to 0. Okay? Number 4. So, limit r tending to infinity. Limit r tending to infinity phi r equals to minus er p1 cos theta plus c p0 cos theta. Okay? So this implies AL will have to be 0 for L greater than equal to 2. AL will have to be 0 for L greater than equal to 2. Does everyone agree? L अगर 2 हो गया, if L is equal to 2, then what will happen? This would have cos square theta term, cos square theta, d by 2, cos square theta minus 1. Right, na? I don't have any cos square theta term. I have only cos theta. I have P0 cos theta, P1 cos theta. I don't have P2 cos theta. P2 cos theta will give me 3 by 2 cos square theta minus 1. Right? So therefore, in all A, because this is what is giving the terms. 1 by r equals to E, r determinant. So all A's must be 0 for L greater than equal to 2. What is A naught? Looking at that. A naught equal to C, very good. What about A1? A1? Who is saying that? A1? बता रहे हो? Yes, very good, very good. A1 equal to minus. What about constants on PLs? Is there any constant on PL? Because BL are 1 by r square, 1 by r cube, इस तरह से जा रहे हैं. Asymptotically, they would all become 0. R tending to infinity, they will all become 0. So there is no constant on PL. Only thing is that B0 is 0. So B1, B2, B3, so at present there is no constant. So there is no constant on PL. So therefore my potential now phi r equals to C minus ER cos theta plus summation L equal to 1 to infinity. I have removed out L equal to 0, right? Because L equal to B0 is not there. PL R to the power minus L plus 1 PL cos theta. I hope everyone agrees to this, right? Phi r is now this. Is there any more boundary condition that is there? Boundary condition is that the potential at the surface would be constant. So that means my phi naught that I consider is the equipotential surface. The potential at the surface when the small r becomes capital R, phi naught equals to C minus E capital R cos theta. The radius of this sphere is capital R. So C minus dr cos theta plus summation L equal to 1 to infinity BL R minus L plus 1 PL cos theta. What do I conclude from that? Number 5. What do I conclude from that? So this has to be constant.
ER cos theta should be
So
equal to
therefore, phi naught equals to C. Phi naught equals to C. These two terms should cancel one another. These two terms will be cancelling one another, that is the constant of phi naught will be constant with it. It will not depend on theta or r, right? So phi naught equal to C, what would be B1? B0 to 0 है. First term is B1. So B1 means this is B1 divided by R square. Right? And so therefore ER cos theta will be B1 divided by R square cos theta. Right? And so therefore B1 equal to ER cube. B1 will have to be ER cube. Right? What about B2 and B3 and all that? सारे 0 होना पड़ेगा. अगर कोई cos square theta cos cube का term है ही नहीं, right? So all the BLs will have to be 0. Only non-zero term is B1. So all BLs 0 for L not equal to 1. Now I'm ready to write down the final potential. Phi r equals to phi naught minus E 1 minus capital R cube by small r cube r cos theta. You must have done this problem in Griffith. We have done it in a different way, but we are using separation variable. We have done this problem again in image method. How do you do it by image method? That is producing the uniform electric field. Because of those charges, you get the image charges, and you have the gravity right, and then right out of the potential. So this is the potential at any point, right? Which is asymptotically going to give you Z cap. R cos theta is Z. Right? Okay. Now that you have got the potential, can you write down the electric field, ER? Potential is given. How will you get the electric field? How will you get the electric field? Gradient of potential. Gradient spherical polar coordinate. Right? So that would be minus gradient of, so that is minus r cap d by dr plus theta cap by r d by d theta. So this is the gradient of spherical polar coordinate over phi r. The phi r expression is, this is the phi r expression, right? So this you have to operate over to a gradient operation on that. Simple differentiation of r and theta is So the electric field will have both r cap and theta cap component. It's not uniform. It's not linearly outward r cap. Electric field will have both r cap and theta cap components. Right? But what happens at the surface? Surface में ये r cap आएगा, तो यहाँ 1 minus 1 0, some theta cap term goes away. Only radial part, as it should be. Electric field will be always normal to the surface, right? Normal to the यहाँ r cap. So electric field at the surface is only r cap dependent. But in general, if you go outside, you will have both r cap and theta cap. Right? Okay. So it's a non-uniform electric field that is outside the sphere. What about sigma r theta? Charge density at the surface. What dependence should charge density have at the surface? Theta dependent. What dependence? तो यही कहा कि एक साइन माइनस हो जाएगा, एक प्लस हो जाएगा. Cos theta dependent. Cos theta changes sign, plus or minus, right? So sigma r theta, the formula is epsilon naught r cap dot er. Epsilon naught, sigma by epsilon naught is the amount by which the surface discontinuity happens in electric field. अंदर क्या electric field? अंदर electric field zero है. बाहर जो है that is electric field. So the discontinuity is sigma by epsilon naught. Therefore sigma equal to epsilon naught r cap er. This is the expression for er. So r cap only this term would survive. And what would be the corresponding answer? 3 epsilon naught e cos theta. 3 epsilon naught e cos theta. So the charge density this side is all plus. Once you go to this side, to minus. That's what it is. What is the total charge induced? Total charge induced is this charge density integrated over the surface. This side. What is the total charge induced? R square d omega. This is solid angle, right? And theta is 35 sigma r theta. जीरो ही होना है. ये cos theta टर्म यहाँ पड़ा हुआ है. इंटीग्रेशन में sin theta है. sin theta cos theta d theta 0 to pi. Always we give you 0. As expected, the charge induced. Total charge is 0. बस plus minus हो गया. Total charge is 0. It's not grounded. Yeah. Right? Good question? Okay. What about the limit r tends to infinity here? If you go far away, you should have the same electric field. Right? If r tends to infinity, what happens to er?
The divisor of the.
So this equals to E r cap cos theta, right, minus theta cap sin theta. This is becoming 0, right? This is very large. R is very large. So this is going away. So theta cap E sin theta, theta cap sin theta. The first term is r cap cos theta. Does it look like E cap? It is.
Yes.
Yes or no?
Yes.
In spherical polar coordinate, so this is my theta, right? This is my r cap direction. This is r cap direction. So if I do the components, right? So this is the theta. So obviously r cap cos theta is z direction. R cap cos theta is z direction. What is the theta cap direction? Theta cap direction is this. Theta cap direction is this. With respect to this should find is 90 minus theta. So theta cap sin theta is minus z. Therefore, this is r cap minus cos theta minus theta cap sin theta is nothing but z cap. Z cap. This is equal to z cap. Right? So if I and asymptotically the electric field is z cap. Okay? So this is an example of spherical polar coordinate. And I think I had wanted to cover much more, but no harm. I'll just tell you the problem. Please to try to do it on your own. If you can't do it, then I will maybe in the tutorial next week to discuss that. So I have a cylinder which is in uniform electric field. So this is my z-axis. And what is this cylindrical coordinates? This is r theta z. R theta z. The plane you have r theta and this is z axis. Right? And so with my ER, the EX cap. So the field is along x cap direction. So this is x, y, z. So the same problem, so spherical coordinate, cylindrical coordinate, try to solve this and try to find out the electric field, find out the charge density, total charge which is taken 0 over rounded except plus except minus, right? Conducting cylinder, long cylinder. And so try to do this instead of P0, P1. All this, you have Bessel function. You have Bessel function in this case, but I need to use. We can discuss this if you can't do it. So tomorrow, next class, we'll go over to polarization. Okay. I will take the attendance. We are going to do it. Spherical vector, cylindrical, you might do, you can't do. Rectangular is easy. Here is our 7th class. Safa is there, right? Blueprint is there. Study Jada is there. Orange Park is there. And the Yale is there. Blueprint is there. Sneha Vaida. Yeah. Thomas Silva is there. Abhiraj is there. Today, Kapil Kumar. Jodi Paul is there. Abhishek Kumar. Chandra Mayan. Vijay Bolan.
5th number boundary condition na beyond equal to 2 okay
ये वो कांस्टेंट है तो ये दोनों कैंसिल आउट होने चाहिए और इसको कंपेयर करेगा तो ये क्यूब है
Sen, Shah Bhai, Sahil Yadav, Jay Lavik, Ash Moria, Karam Mila, Joseph, Jessica Tiwari, Pushpa, Ishita Ajarika, Shivam Mishra, Mohammad Saqib Raja, Shah Bahadur, Yogendra Singh, Kashish Tiwari, Mahatma Jain, Amish Verma, Anish Pandey, column E, Murshid Sahab,
Yes.
Chaudhary Sahab Ghazi, Neha, Kumar Yadav, Bhagwan Raj. This is moved by Ashok Das.